And hey everyone, welcome to my talk on the autonomy of credential stuffing attacks. I'm Jamie Hughes, I'm one of the lead solution engineers here at Auth0. For those that don't know, Auth0 is an identity as a service platform. We were founded in 2013, and today we handle over 4 billion logins every month for roughly 9,000 customers across the globe. Without going into all the detail, we basically make authentication easy to implement. And since handling authentication, being the front door to many of these organizations is our daily business, we obviously deal with credential stuffing attacks fairly often. So, agenda for today over the next 30 minutes, I'm going to give you a quick definition and introduction into credential stuffing attacks, what they are and why we're hearing about them a lot at the moment. They're very common. We're going to look at the key enablers that make credential stuffing attacks very possible, very easy, and also very lucrative. We're then going to talk about some of the impacts these attacks can have on businesses who fall victim. And then we'll finish off with ways to help mitigate the risks and the defenses that organizations can put in place to actually defend against these attacks. So starting off, what is a credential stuffing attack? Two words here, right? Credential stuffing. Credentials are a set of claim and proof. So this is, in most cases, this is an email address, a username, and then the password is a secret, right? It's a password that the user knows, they create. Hopefully they used a password manager to generate a secure password. And they use that password, they use that combination to gain access to some form of account service. And then the stuffing part, it basically, mass testing, sending mass requests. So, credential stuffing attack, it's a cyber attack. It's a type of cyber attack. And the definition really is where we're using breached, compromised account credentials, typically from a third-party data breach, a breach against a different site, and using those in mass requests to gain unauthorized access to a user's account for a particular service. So, what's involved, the process and components. So if we look at the first column there, the first one is these breach lists. These combinations of email, username, and passwords that are available today on the dark web, on the surface web, where that breach, that data breach, that data is available in what we call these breach lists. Now they're kind of the foundation for these attacks. These are going to be injected into the attack for all of these requests. The next point here in column 2 is the botnet and the tools they use to actually perform these attacks. And so, as I said, these breach credential lists are loaded into those tools, and then a single credential, a single username and password combination is then injected into that request. And now that request is, as I said, is being automated, typically botnet scripted, and they're targeting particular services. So they're targeting the authentication endpoints of a particular organization, of a particular service. And these attackers will typically run these attacks in parallel across multiple sites. They'll run them for a long period of time, and then they're monitoring, they're assessing these attacks and looking for successful login attempts, so therefore successful credentials. They will then mark that account, the value associated to that account, and then they'll actually package that up and then sell that on a marketplace. So looking at the last column here, the bad actor is actually then packaging that up and putting that up for sale on a marketplace. So typically, targets of these attacks are where services are offering, in an account-based, some value attached to that. So subscription services in the example here could also be loyalty schemes. They can then, from performing these attacks, gaining access to these accounts, they're then making a good profit. Now, obviously, these are typically sold at a lesser value than the actual market value of whatever that account service is. And if we have a look at this in the news, so attacks we've seen this year, we had a UK supermarket had to suspend 620,000 accounts after stolen password and username combinations were used to actually gain access to these accounts. Now, what they did is they redeemed their reward vouchers that they'd collected via the loyalty scheme. So the actual supermarket, for each of those customers that were impacted, then had to replace the points and the vouchers. They had to reissue them a new loyalty account, and also the users had to reset their password. So big impact to the business there. Also got another global media streaming service, went live earlier this year. Within the first week of launch, thousands of these accounts ended up on a darknet marketplace available for sale at a lesser cost than what the actual subscription cost was. Now, the actual media streaming service here actually denied there was any form of data breach or compromisation of their service, and therefore we can only deem that this was related to a credential stuffing attack. And then another UK retailer again, March this year, loyalty scheme again, and they had to suspend their entire loyalty scheme in-store online while they resolved this issue. The retailer did confirm there was none of their own systems compromised. It was the fact that there was a credential stuffing attack where combinations of these credentials were used from a different data breach to therefore target their service. As I mentioned at the start, right, Auth0, very unique position here. Identity as a service, front door to many organizations, 9,000 customers, over 100 million logins per day, 4 billion successful logins per month. So we therefore see a lot of traffic, a lot of data to analyze. We know that credential stuffings are a huge, industry problem at the moment. And at any one time, 67% of traffic coming via Auth0, so all traffic, is deemed malicious. So let's have a look at how credential stuffing attacks work and the key enablers of these attacks. So the first enabler here is the fact that, single factor username and password authentication still exists today across a number of services. If I look at this article here from CNET in 2004, it quotes Bill Gates saying that at an RSA conference, there is no doubt that over time, people are going to rely less on passwords. Well, that was 16 years ago. It's now 2020, and things haven't really changed that much. Me as a user, for a good majority of the consumer services that I use, I'm still only offered the choice of single factor username and password. I type my email address, I type my password, and I gain access to my account. There's been some improvement. Some of those services are now offering MFA as an optional factor. Some do offer it as a mandatory next step, security step. And me being a security conscious user, I will always implement MFA where I can. But for a less security conscious user using those services, they're likely to not enroll MFA. Some users see it as extra friction. Maybe it's a bit complicated for them to actually do that, and therefore those accounts are left vulnerable. We kind of talked about this kind of passwordless journey and passwords disappearing. That is the future. The future is a kind of true passwordless where a user no longer needs to use a password. We are getting closer, but I think that's a topic for a different day. The next enabler here is breach credential lists. So, these lists are out in the wild in the number of billions. And so, a lot of these lists are available via different marketplaces. The chances are some of your credentials have potentially been breached and they're available in some of these lists. And let's fingers crossed that you've identified that already and you've reset that password and you're no longer using that password across any of your sites. Now there's a tool here, website called Have I Been Pwned? And this provides a way to check if your email address was included in any breaches. And if it was, it shows you the breach site as well as the date it was breached. You can actually see on this site as well some of the largest breach lists that are actually out there on the dark net and the surface web. And you'll also be able to see which database when it was added to a database. They also provide an API as well, so you can actually query this programmatically, or developers can query this. Again, passing an email address to get details of whether it was breached, the site, and also the date. There's a huge number of forums out there. Here's quite a popular one called RAID. They have around 7 billion records from over 370 different databases. These databases can be purchased, and some of them are even free to download. So again, very easy for attackers to get their hands on these actual credentials. And obviously the ones that are paid, maybe they're going to be slightly more reliable, successful credentials. Maybe they're more recent, they're not out of date. And therefore maybe they'll have a more successful attack. So therefore they typically have to buy those lists before they can gain access to them. But how do these credentials get leaked in the first place? Where did this data actually come from? Obviously, credential stuffing, as we've just talked about, uses exposed data from breaches, but it has to be captured from somewhere. If we look at brute force attacks, which is a different kind of attack, that's really using where they're guessing. They're guessing passwords. They're using random strings or maybe common password suggestions, but it's not actually previously proven user passwords. So, one way that was very popular for Windows environments was to use, Trojans, malware that, somehow the user accidentally installs this on their machine without realizing. And then it installs, it's installing some form of keylogger in the background. It takes screenshots and so on. And effectively, it's just recording the user's credentials as they're typing them into, a website or a desktop software. And therefore, then they get added to a database. And there you go, the user's password's been compromised. We then have, obviously, your standard phishing attack, tricking a user onto a website that isn't actually the one that they think it is. So this is, this is the standard phishing attack that we all see, all the time. In this example here, the user's been tricked onto a PayPal site. Now, to a more security conscious user, we can kind of identify that this isn't actually PayPal itself. You can see the URL is not PayPal's domain. More security conscious users would not fall victim to this. But again, there's a lot of non-security conscious users out there. And if they get an email which is worded with some kind of urgency, some kind of security issue, they may very quickly click the link, log in here, and before they've realized it's a fake site, the actual attackers who owns this phishing website has now added their credentials to a database because obviously the users just typed them in. We've then got, insecure databases, servers, S3 buckets. So this is where the attacker's not going via the front door, they're going through the back door. And this is where, the organization you're a user of has actually let you down. They've not put the right processes in place to ensure that your data is secure. So maybe they gain root access to a database, or they trick the database with some kind of SQL injection. Or even easier than that, there was a case in 2019 where an AWS S3 bucket had the wrong permissions. It had public access permissions. So that attacker could actually just download that database, and that database contained very, very sensitive information on end users of some big brands. Password reuse. I've mentioned this a couple of times already. It's the next big enabler. So if we look at users out there who use services online, the average user has 26 online accounts. Now, this was a study from Shape Security. And apparently that number increases to 40 where the age demographic is lower. The average user has roughly 5 passwords, which means obviously if you do the maths, they reuse this password anywhere between 5 and 8 sites. So you couldn't really imagine the proportion of passwords being reused for users out there. And now we move on to kind of the real other key enablers, these automated, bot tools that we talked about, automated scripts, and these tools that are available for these attackers to actually perform these attacks. And there's a vast amount out there, as we're going to look into now. So, believe it or not, for various, popular websites, there is actually, specific tools out there that are already targeted to, aimed and configured to target that organization. So if you did a search, in a darknet browser for whatever platform you want to attack, account checker or account attacker, you'll find access, and you can see on the screen here some of the big names that are available out there, where these scripts are already pre-configured to attack these systems, and really, they just help streamline that process. So from this point, the attacker doesn't need to build their own script, doesn't need to build their own botnet and do all that work themselves. It's already readily available in a marketplace that they can simply purchase. Or sometimes they may even be free. If we dig a bit deeper, we can see one here specifically for Adobe. This is a more sophisticated tool. It allows you to input multiple breach lists, as a parameter for the attack. It allows you to set the number of threads that you want to run in parallel. So if we look at credential stuffing attacks and some of the more sophisticated ones, they're sending a very small number of requests per a unique IP address. And maybe they time that to go under the organization's velocity-based defenses. So only sending a very small number of requests per minute, whatever that may be. And so this tool here allows you to add a list of proxies, which then, as I said, allows the attack to send out a number of requests per unique IP address, rather than just sending them all via one or two, which may get blocked by those velocity-based defenses. The other key thing here is it actually will scrape the account for you and see what value is attacked. So if it does find a successful account and gains access, it will actually pull the data from that account, so you know exactly what a value is attached to that account, right? Which is key for these attackers as they then advertise these accounts on the marketplace. They know exactly what value that account is worth as well, and these tools provide all of that out of the box. We then move on to talking about proxies and IP addresses, and it's very, very easy for these attackers to now source tens of thousands of IP addresses, and also not for very much money. We see here getting a list of 10,000 global IP addresses only cost $10. There are also free lists out there as well, but obviously in terms of getting IPs with a better reputation, more specific to maybe a particular region. An attacker would typically buy these IP addresses, and obviously, as I said, they're not that expensive. Years ago, this wouldn't have been something an attacker would have worried about. They would have just got access to a few IP addresses and sent mass requests, thousands of requests per those few IP addresses. Whereas now, that behaviour is changing. At Auth0, we're seeing that as a common pattern, that the attackers are now sending a very small number of requests per unique IP address. So having access to tens of thousands IP addresses as part of an attack is very, very lucrative. And actually what users don't realize is users will use these cheap free VPN tools. And actually what's actually happening there is that, they're actually, by doing that, they're actually providing access to these proxy lists. There's maybe a sister company or a joint company where they're then turning their users' exit nodes as part of that VPN and stealing their bandwidth, and actually using their residential IP addresses to then form of these proxies that they're selling online. And then the next one is browser automation studio kind of tools. So we're looking at tools that allow you to emulate user interaction in browsers or as part of a desktop. These tools, the official tools, are typically used in software testing. So, you script the user interaction through the browser for, whatever that user may do as part of that website. However, again, there's these tools that are specific for credential stuffing attacks. And again, they're available on the darknet. This one here, Browser Automation Studio, is one of these tools. It's more categorized into one of the more malicious tools. It offers add-ins as well, which we'll talk about in a second. So, the idea here is just to mimic a real user. So instead of just sending, login request against an API, this is actually mimicking the user in a browser. For each of these, when you set up one of these scripts to run in a Browser Automation Studio, you'll have to target it for a specific site. But again, on some of these marketplaces, they actually have these already pre-configured to target particular sites. We can also, look at the marketplace here as well. So more advanced features of these is that the ability to, add a capture solver. And captures, I'll talk about that in a second, but obviously they're added into login sign-up flows to, prevent exactly, specifically against bot attacks and botnets. And these automated scripts so that the user actually has to solve the captcha in real time in order for their request to be processed. They've also got a browser fingerprint switcher as well, which we'll talk about in a second, very similar to how you can switch out IP addresses for requests. And, so captures, as I said, it's Google reCAPTCHA here. It's a service offered so that the user in real time has to solve that challenge as part of a login request or a sign-up request to prove that the user is not a bot. And you'll see these on probably a lot of services you'll use today. But again, not an issue, not a problem for these attackers. There are plenty of capture solving services out there, again, available via the darknet. And again, it will access very, very cheaply. There's one out here, as you can see, called Death by Capture. And this is available, I think it's like, you can get about 1,000 captures that are pre-solved for a little over kind of $1. But the way they can work can differ. Some are purely based on OCR, some image recognition. Others provide APIs so that the attackers can actually integrate these capture solver services into their attack tools. And actually on the other end of this, there's real people sitting there solving these captures in real time. And then the last one here is similar to being able to buy proxies, being able to buy a huge number of IP addresses. When we talk about browser fingerprints, so I'm referring, when I say browser fingerprints, I'm referring to characteristics specific to your browser. from the headers that identify the browser and operating system when you're interacting online and with websites. So, if me and you are both using Google Chrome and a MacBook and visiting the same website, that browser fingerprint still allows the service to recognize that we're actually two different users, without even looking at the IP address. So again, defenses in place that organizations may have in place, may be looking and limiting the number of browser fingerprints that are used in these requests. So therefore being able to have access and buy these kind of compromised and readily available browser fingerprints to switch these out as per request, so they're not going to get rate limited there. And the last enabler is the marketplace availability, right? So this is actually being able to sell the compromised account, and if there wasn't a demand for it, then these credential stuffing attacks wouldn't be as lucrative and as popular as they are today. So there's definitely people out there that want to buy these compromised accounts for a lesser value than what they're available on the actual service. And just to quickly clarify here, I've mentioned the terms kind of dark web and surface web. So we have like the surface web, which is the publicly available web, right? It's the publicly visible index websites that we find in search engines. Users are using this on a daily basis, the one we use on a daily basis. We then have the deep web, which is sites and pages not indexed, but publicly available if you have the direct URL, and in regular web browsers, so Google Chrome, for example, ones we use every day. And then we've got the dark web. Now this consists of pages that are not indexed, and they're only reachable with kind of special browsers, so browsers such as Tor or I2P. And this is really what we've been talking about today. This is where the ecosystem for credential stuffing attack mainly exists. So all of these tools that I've been talking about, all of these breach lists, mainly available in that dark web. And then we look at a marketplace available on that dark web, right? So this is similar to the shopping platforms that are offered with Amazon or eBay in marketplaces. So these attackers can set up their shop, they can put their compromised accounts online. Again, there's no need for them to develop their own shop, their payment gateways, it's all there available, as you can see here on the screen. So they can then sell these accounts with minimal effort. So from what you can see from all of these enablers, right, it's like an end-to-end solution, attack as a marketplace or attack as a service. So, whilst attackers could build their own automated scripts, bots, they don't need to. It's all readily available for them at a very small cost. So a quick look at business impact. What impact can these attacks have on your company? So the main impacts here is reputation, loss of revenue, increased operational costs, and also look at some GDPR and data privacy regulations as well, and the impact they can have on organizations. So very quickly on these. So reputation, obviously damage to brand reputation. If you're full victim to a credential stuffing account and you have accounts that are compromised, as we saw earlier lines on the news, you're going to get negative PR, negative media coverage. Which means that your users are going to see this and they may choose to use to a competitor service, due to the loss in confidence, loss of trust in your brand. They may no longer feel comfortable actually storing data with you. And so, not only do they choose to move to a competitor service, maybe they choose to store less data with you. So it means that, the ability for your marketing team to better offer personalized content or market to the users, that becomes an issue as well. And that negative association can last for years. You're having a conversation with your friends, with someone from work, and someone mentions that brand name, and the first thing that brings to mind was, that big data breach that they had. So that negative association can last for a while. Loss of revenue. So I've mentioned earlier, you may have to suspend your services. There may be downtime involved, suspending loyalty schemes, for example, suspending the ability to earn and spend loyalty points, which ultimately will lead to a loss of revenue, particularly prevalent, as I said, in e-commerce, subscription services, loyalty schemes. And then potentially customers, whilst that service is suspended, they move to a competitive service. And then you've also got the reimbursement of credit. So if your actual customer loses their loyalty points, loses whatever that value attached to that account is, you as an organization, you're liable to reimburse that user as well. Increased operational costs. So, what we're seeing actually is the attackers aren't actually just targeting the login flow, they're targeting the sign-up flow as well. So we're called synthetic account creation. So they'll actually create thousands, if not millions of fake user accounts in your database if you don't have the right protections in place to stop that. Why they do this, we're not sure. It's more of just a nuisance. It basically involves a poor user experience as well. Me as an actual user, I come to log in, sign up for your services. It tells me I already have an account. I end up calling support, and that leads to, additional support center costs. You've also got the investigation into this as well. Hang on a minute, why have I got all these fake accounts? Which takes consultancy time to actually look at that. You have to pull your employees away from, their actual day job to investigate these attacks, and therefore they're losing, kind of the actual value add, and they're diverted away from their day job, which adds value to your service. The other side of this is the computational cost of handling these attacks as well. So, if you're 100 million requests again, for example, against your service, that actually has to be processed and computated. So those credentials, if you haven't got the right defenses in place, they actually have to be processed, which leads to increase of those costs there as well. And then the last one is GDPR and data privacy regulations. So let's say the attacker does gain access and they actually manage to get hold of a user's personal or sensitive data. That's a breach of confidentiality, a breach of that user's data. And these GDPR, California Consumer Privacy Act, they have large fines for these type of data breaches. And again, your organization could be liable for those fines as well. So moving on, last point, mitigation. How can organizations actually mitigate and defend against these? So I've already talked about this. About 67% of that total traffic, so a huge amount of traffic being aimed at these services. So how do we defend? How do we identify? It's always a good idea to actually constantly look at the analytics of your login traffic and benchmark that traffic for normal patterns, normal days, periods of the year, and then identify if all of a sudden you're seeing a huge spike in kind of invalid, failed username and password requests. And therefore it's easy to identify if you're under some form of attack, and then you can start to look at how you can quickly prevent and block against that attack. This is just one example of all of a sudden a huge spike to up to nearly 600,000 failed login requests. Then look at, the other side of this, the number of the count of unique IP addresses, the failed login attempts against those IP addresses. So you can kind of benchmark your velocity-based defenses and understand where that traffic patterns are coming. In the examples here, you can see that actually all of this traffic was allowed because the attacker was sending a very small number of requests per unique IP address, and probably over a long period of time as well. And therefore it was going under the velocity-based defenses. So therefore understanding kind of the vector of that attack is key to being able to defend against it. You can also see this example here, and all of a sudden a huge spike of traffic from a different location where you wouldn't expect your users to be authenticating from. So therefore, again, in this scenario, very easy to identify that. But then it comes to the question, well, how do I defend against these? And the key answer here is layers. So I'm going to talk specifically about 3 features, and one is bot detection, one is some kind of breached password detection, and the other is the multi-factor authentication. So here at Auth0, what we're doing is we're assessing all of this traffic. We're from sign-up events, login events, and we're feeding that all into one big engine, which looks at velocity-based attempts, against a user account, against an IP address. We're assessing is the user using a set of breach credentials. You're looking that up in a database to see if actually that user is using a combination that's been breached. We're then looking at things like the IP reputation. Does it belong in blacklist? Have it previously belonged on a blacklist? Domain reputation, email reputation, then looking specifically at the user's geolocation history. Where is that genuine user logged in from before? What devices have they used? And also their IP behavior. So then you can determine in real time if actually something suspicious is about this. We've never seen this user from this location before. So why is that user logging in? And it feeds into what we call a confidence score. So then you can identify in real time how confident you actually are that you believe this is actually the end user. And if that confidence score is low, you can then block or you can challenge the user on top of their first factor, or you can actually insert a capture into the login request to prevent against that. So all that data is key in these following defenses. So, bot detection, as I said, it's using data sources from IP blacklists, from IP addresses which you've seen previously attack your services. And you can actually then determine whether you're going to process that request or whether you're going to block or challenge that request. So, you see, so we talked about captures, you see captures out there, which will actually, the capture challenge is, the answer to that challenge is required as part of the request. So it must be provided in addition to the email and password. And therefore, when we talk about processing all of those requests up front, with some form of bot detection, you're actually protecting and stopping those requests before they're processed. So really slowing down those attackers and reducing the malicious traffic that's being processed. At Auth0, we keep our own database of these known breach credentials. So every time a user logs in, we do a lookup to see if that user is using a breach list of credentials. And then from that, you can determine whether you want to, notify the user, suggest they perform a reset because their password has been breached on a third-party site. You could challenge them again with MFA, or you could just block the login, and therefore that account can never become compromised if an attacker uses their account, their account information in a breach list, in a credential stuffing attack. And then the last one here is multi-factor authentication. So obviously this is an additional layer. So where, username and password authentication is used as the first factor, this is then actually an additional step the user needs to complete. So, if the attacker is using a breach list and those users' combinations do exist in those lists, and they manage to get a successful first factor, there's still multi-factor, which is actually preventing the account takeover. So the attacker, will still be able to identify that they've found a successful set of credentials. So that means that list is actually up to date, because that user may well be using that password still actively today on this site, maybe other sites. But for this specific site, it prevents against the account takeover. It prevents the user account value from being stolen and sold on a marketplace, because the user needs to type in get some OTP sent to their software TOTP app, their SMS number, or maybe a push notification, or maybe a physical token. So therefore, multi-factor is a key way to prevent against credential stuffing attacks and account takeovers. And with that's all I have for you today. Thank you very much for your time. I hope you've enjoyed the presentation.